Every year, millions of tons of traditional plastic threaten our planet's delicate ecosystems. This environmental crisis demands a radical shift in how we produce materials. But a revolutionary solution lies hidden within seafood waste: shrimp shells. We are about to explore the journey from discarded shells to transparent bioplastic. The complex structure of these shells is more than just waste. It is a source of high-quality organic polymers that can be re-engineered for sustainability. Inside these shells lies chitin, a natural molecule with incredible strength. Our mission is to extract and transform this polymer into a versatile modern material. This advanced facility combines biology and chemistry to solve the plastic problem. Scientists and robots work in harmony to pioneer a new industrial era. Every shell is treated as a valuable resource. Through precise analysis and processing, we unlock the hidden potential of what was once considered industrial garbage. Stage 1 begins with pre-treatment. High-pressure cleaning removes impurities, ensuring that only the purest organic matter continues into the refined manufacturing stages. The shells are gathered and prepared for physical transformation. This automated process ensures consistency and efficiency, paving the way for large-scale bioplastic production. Next, we employ ultrasonic grinding technology. This advanced method uses high-frequency sound waves to begin breaking down the physical structure of the shells. This technology targets the calcium carbonate bonds. By shattering these mineral layers without damaging the natural polymers, we preserve the integrity of the chitin. The result is a fine, uniform powder. This raw material is now ready for chemical purification, having been physically optimized for the next reaction. The uniformity of this powder is crucial for reaction speed. Every particle is sized perfectly to allow chemical agents to penetrate and refine the material. Real-time monitoring ensures that the physical properties of the powder are perfect. We maintain strict control over every variable to guarantee the highest quality bioplastic. We now enter the chemical refining phase. In these closed reactors, the shell powder undergoes demineralization to remove calcium and other unwanted minerals. Hydrochloric acid is introduced to dissolve the mineral content. You can see the carbon dioxide bubbles forming as the acid reacts with the calcium carbonate. At the molecular level, the calcium is stripped away. This leaves behind a flexible organic matrix, bringing us one step closer to pure chitin fiber. The next step is deproteinization. Sodium hydroxide is added to carefully remove proteins from the matrix, ensuring the final plastic is clear and odorless. Proteins are separated from the chitin chains. This purification process is vital for the material's structural stability and prevents any biological degradation during use. Thorough washing follows every chemical step. We ensure that no residual acids or bases remain, creating a clean and safe base for our final product. What remains is pure, white chitin. This material is the backbone of our future bioplastic, now completely free from the minerals and proteins of the shell. Gentle heating removes any remaining moisture. Precise temperature control prevents the polymer from becoming brittle, maintaining its natural elasticity and strength for later stages. Centrifugation further refines the chitin. This high-speed process separates any remaining microscopic particles, ensuring the ultimate transparency and purity of the resulting bioplastic. The refined chitin is now ready. It is a powerful organic material, but to make it soluble and useful, it must undergo one more transformation. We now initiate deacetylation. By applying high heat and concentrated alkaline solutions, we transform chitin into chitosan, making the material soluble and formable. At the microscopic scale, chemical groups are removed. This structural change is the key that unlocks the material's ability to be dissolved and molded. The resulting chitosan is dissolved in a mild organic acid. Watch as the solid powder transitions into a viscous, clear liquid, ready for casting. Continuous stirring ensures a perfectly homogeneous gel. This consistency is vital for creating uniform plastic sheets that have the same strength across their entire surface. The gel is thick and rich with polymer chains. These chains will soon interlock to form a durable barrier, mimicking the properties of traditional petroleum-based plastics. Air bubbles are removed under vacuum. This step is essential for optical clarity, ensuring the final bioplastic is as clear as glass and free from defects. The liquid material is now ready to take shape. It flows smoothly, guided by robotic precision to ensure the exact thickness required for its intended application. Self-leveling properties create a flawless surface. The material's high surface tension allows it to form a thin, even layer that will eventually become a strong film. As the solvent evaporates, the polymer chains begin to find each other. They form strong hydrogen bonds, creating a dense network that provides impressive mechanical strength. The material enters the curing stage. It travels through a controlled environment where temperature and humidity are perfectly balanced to facilitate the final solidification process. This is the heart of the production line. Large-scale rollers cast the chitosan gel into continuous sheets, allowing for mass production of this eco-friendly material. Laser sensors monitor the thickness with extreme precision. We ensure every square inch of the film meets strict industrial standards for durability and performance. Infrared heat speeds up the drying process. This targeted energy efficiently removes the solvent while maintaining the structural integrity of the bioplastic's molecular arrangement. The film becomes solid and strong. What was once a liquid gel is now a durable plastic, thanks to the controlled removal of the liquid carrier. The first sheet of bioplastic emerges. It is completely transparent, flexible, and surprisingly strong, marking a major milestone in sustainable material science and engineering. Visual inspection confirms its quality. The clarity is comparable to petroleum-based plastics, proving that we don't have to sacrifice performance to protect our planet's future. The finished product is rolled for storage. These spools of bioplastic will soon be sent to manufacturers to be turned into a wide variety of eco-friendly products. The material is versatile and easy to process. It can be cut, folded, or heat-sealed, just like traditional plastic, making it compatible with existing manufacturing infrastructure. Precision is maintained at every level. The smooth finish and consistent density of the material are a testament to the advanced industrial process used in its creation. Inventory is prepared for distribution. This marks the transition from a laboratory concept to a viable industrial reality that can serve global markets and industries. Rigorous testing is performed on every batch. We measure tensile strength and elasticity to ensure our bioplastic can withstand the demands of real-world use and transport. The applications are diverse. Its natural antimicrobial properties make it the perfect choice for food packaging, extending shelf life while remaining completely safe for consumers. In medicine, its biocompatibility is a game changer. From pill packaging to surgical films, this material offers a sterile and sustainable alternative to synthetic polymers. Even electronics can benefit. The material's insulating properties and durability allow it to be used in consumer tech, reducing the environmental footprint of our favorite gadgets. The most important feature is its end of life. When buried in soil, it completely biodegrades within weeks, returning to the earth as nutrients instead of harmful microplastics. It leaves nothing behind but life. This true circularity ensures that our materials support the environment rather than destroying it, creating a healthier world for everyone. A future without plastic waste is within reach. By choosing materials derived from nature, we can transform our economy into a sustainable system that respects the planet. This is the circular economy in action. We take from the sea, create value, and return to the land, closing the loop of production and consumption. Manufacturing bioplastic from shrimp shells is more than just technology. It is a commitment to a waste-free future and a promise to protect our oceans. The industrial process of the future is here. Together we can build a greener planet one shell at a time. Join us in this sustainable revolution.